All right, 16.1, task 5. So today in this problem, we're going to be tackling a real worldish type problem. So propane delivery trucks come in a variety of sizes, but nearly all of them have tanks that are cylindrical with hemisphere ends. Hemisphere meaning half a sphere. So this end on this is half a sphere, and then this one on this end is half a sphere. Okay. What polynomial expression models the volume of the tank? Okay. So first, this tank is made up of two different things. It has the cylinder that makes up like this middle piece. And then it has the two hemispheres. It has these two ends, which if I put them together, it's going to make one sphere. So really, I will need to find the volume of the cylinder. We'll call it volume sub 1. And then the volume of the sphere, volume sub 2, and add them to get the total volume. The total number of cubic, again, we're looking for the number of cubic units that are like the number of cubes that would fit inside this tank. Okay, so first I need to find the volume of the cylinder. So for the volume 1 of the cylinder, I need to know the volume of a cylinder. If you don't, the volume of a cylinder is pi r squared, which is the area of the base, times the height of the cylinder. Okay, so it's very similar to our prism because this pi r squared is just the area of a circle. So if we want to find the volume of this cylinder, first of all, they tell me that the radius of this sphere is r. Well, this circle and the circle of the sphere are really the same circle because they meet up right here and they meet up evenly, so they're the same. So the radius of this base is also going to be r. And then this distance here is the height between the bases. So that would be this height right here, 3r plus 4. So the volume of that cylinder would be pi r to the second times 3r plus 4 times that whole thing. So if we distribute this out, I would have 3r times pi r squared, which is going to give me 3 pi r to the third, plus pi r squared times 4, which is going to give me 4 pi r to the second. Okay, so that's the volume 1 of our cylinder. So volume 1 of the cylinder is 3 pi r to the third plus 4 pi r to the second. Now we need the volume of the sphere. Well, the volume of a sphere, volume sub 2 of our sphere. Okay, these little subscripts down here are really just determining, basically allowing us to use the same V, but they're different V's. One's the volume of the cylinder, one's the volume of a sphere. The volume of a sphere is 4/3 pi r cubed. Well, the radius of this is r, so it's just 4/3 pi r cubed. There's the volume of it. So that's the volume of the sphere, 4/3 pi r cubed. So I now need to add them to get the total volume. So we look to see, it's all strictly addition, add. Do I have any like terms? Pi r cubed, we have to include the pi when we're looking at the variable parts. So yes, those are both pi r cubed. So really I have, and this is a pi r squared, so that's not like terms. So I need to take 3 and add 4/3. So let's grab my calculator. I need to take my 3 and add 4/3, and I get math, enter, 13/3. So it would be 13/3 pi r cubed plus 4 pi r squared. So there is the expression for the total volume.